Guess who's back? It's another math episode from Listen Back. Alright. So, today we're going to be going over our task number 6 for scientific notation and review for test 3. The first thing we're going to run into is writing these numbers in scientific notation. Now, before we go over question number 1, the first thing I want to dive into is that we're going to be making big numbers and small numbers much easier to handle. Now, I know some of you might be thinking, when am I ever going to use this? Well, whether you're comparing distances between planets or talking about the tiniest things like atoms, scientific notation is a tool you'll need. So in question number 1, we want to write this number in scientific notation. When converting a small number like 0.00004 to scientific notation, the first step is to move the decimal point to get a number between 1 and 10. Here, we move the decimal 5 places to the right. Let's take a look. 1, 2, 3, 4, 5. Once I move it over there, the number we're making is 4. So the scientific notation would be known as 4 times 10 to the negative 5th power. Quick tip, whenever the number is less than 1, like this example, the exponent will be negative because you're moving the decimal to the right. One common mistake is forgetting to count the number of places you move the decimal correctly, or simply using the wrong sign on the exponent. Remember, if it's a small number, the exponent is negative. So why do we use scientific notation? It's like a shortcut. Instead of writing a number like 3,740,000, which takes up space, we want to write it in a way so it can be shorter, a little bit more cleaner. So let's take a look at this example. In an example like this, again, our first goal is to express this as a number that fits between 1 and 10. Ideally, we'd want our decimal to land right over here. So it ends up being 3.74, right? And we're going to be multiplying that times, let's see how many decimals we need to move it over to get to the end of our number. 1, 2, 3, 4, 5, 6 times 10 to the 6th power. Since I've been teaching this since last year, I realized that some students might forget that for large numbers, the exponent is positive. A helpful way to remember is if it's a big number, the exponent tells you how many times you're multiplying by 10. Now the Uno reverse card comes out. For questions 3 and 4, we're going to write these numbers in standard notation. Question 3, 3.72 times 10 to the negative 5th power. That negative exponent tells us we're dealing with a small number, so we move the decimal 5 places to the left, giving us this decimal that's about to pop up. Starting us off with the decimal that gave us 3.72, and we're going 5 places to the left. 1, 2, 3, 4, 5. Place my zeros in there. 1, 2, 3, 4. And now my new decimal is right over there. So our final answer reads like this. Now imagine, this is like trying to measure something super small, like the thickness of a strand of hair. That tiny measurement is easier to write in scientific notation. Now let's go on to question number 4. Here we have 8.92 times 10 to the 7th power, and this is a big number, so we move the decimal 7 places based on that exponent to the right. Let's take a look at what it gives us. Starting off with the decimal that they provided us, now we're going over 7 places to the right. So positive exponent, 3, 4, 5, 6, 7. Add the zeros, 1, 2, 3, 4, 5, and the new number we end up looks like this. Now, even though most of us know it, I just want to make sure when we're putting in the commas, we count from the back of the number. So I'm starting from where this 0 is over here, and we're just going to be counting from there. 1, 2, 3, 1, 2, 3, and the new number we're looking at is 89,200,000. Now on to question number 5, where we're going to express each product in scientific notation. Notice we're referring to the product. And since we're referring to the product, the one thing I want to make sure I emphasize is we're going to be multiplying. This time starting by multiplying the coefficients. Those are the numbers that will be in front of those two multiplication symbols, specifically the ones inside the parentheses. So for question number 5, we have the 2.3 and the 1.5. So you want to figure out 2.3, do that on the side, times 1.5. I'll do the work, and we get a product of 3.45. Now we're going to go ahead and multiply our value to the exponents. That's 10 to the 4th times 10 to the 6th, and anytime we're multiplying, we add the exponents. 4 plus 10 gives us 10. So the answer will be 3.45 times 10 to the 10th power. Now let's move on to question number 6. This time multiplying the coefficients, 5 and 1.8. Now I personally love the number 18, so I'm going to pretend the decimal is not even there. And when I do that, 5 times 18 will give me 90. But since there's a decimal there, I got to bring it back, and I'm going to treat it like it's 9.0 or just simply 9. Then we need to look at our values of the exponents, the 10 to the negative 6 and the 10 to the 9. Again, when we have powers of the same base, we add their exponents. So I'm just going to write it on the side. We have 10 to the negative 6, and I'm going to be adding 9 to that. And if you're having trouble with that, I want you to think to yourself, there are a total of 6 negatives and a total of 9 positives. Altogether, there are more positives than negatives. So that lets us know our answer is going to be positive. All right, and there happens to be 3 more positives than we actually have negatives. So that lets us know our answer is going to be 9 times 10 to the 3rd power. And we leave our answer in scientific notation. Now on to question number 7, we're going to be expressing each quotient in scientific notation. I want you to think the opposite. To divide, first divide the coefficients, 4.8 divided by 1.2. Pretend your decimals aren't there. We treat it as if it's 48 divided by 12, and that gives us a quotient of 4. Now when I look at the other part, the 10 to the 9th power divided by 10 to the 4th, you just need to remember, when we're dividing, we then subtract our exponents. 10 to the 9 minus 4 will be giving us 10 to the 5th power. And that's it for question number 7. Question number 8, last question. First thing you want to do, similar to before, we're going to go ahead and divide the coefficients. 9 divided by 4.5, we know that's half. Alright, so that ends up giving us 2. Now look at the next part. 10 to the negative 3rd divided by 10 to the 7th. As a reminder, powers with the same base means you subtract the 3rd power minus 7. Now the good thing is that they're both going in the same direction, negative 3, and we're subtracting 7. We're going more negative. So that ends up giving us negative 10. So that's going to be 2 times 10 to the negative 10th power. And that's it for question number 8. And just a closing as we wrap up the video, when you're solving these problems, focus on the steps. First handle the coefficients, then work with the exponent. And don't get tripped up by the negatives or positives. The exponent just tells you which way to move the decimal. You can think of it when you're on the LIRR, going into Manhattan. The bigger the number, the further you're going. So scientific notation is like making sure you have the right ticket for either a long trip or a short trip. And that's it with Mac. Have a great day.